Hello everyone! The topic that we're going to discuss today is about quadratic inequalities. First, we're going to identify whether the given is quadratic inequality or not. Number 1, x squared minus x minus 6, is it quadratic or not? Next, 3x squared minus 4x minus 7 equals 0. Quantity of x minus 4 times the quantity of x minus 2 greater than 0. Number 4, x squared minus 8x minus 16 less than or equal to 0. And 2x squared minus 5x minus 10 greater than 0. Now, we're looking for quadratic inequality. Now, if this is not an example of quadratic inequality, then write not. Okay, number 1, x squared minus x minus 6. Okay, there is no equality sign nor inequality sign, but there is a degree of 2. Therefore, that is just quadratic, but not quadratic inequality. Number 2. Okay, it is quadratic because there is degree of 2, but there is a symbol equal that is for equality, not inequality. Okay? Therefore, this is not quadratic inequality. While number 3, okay, so it is not obvious that it is an example of quadratic because you have to do first is multiply x and x so we can obtain the degree of 2. Therefore, this is quadratic and it uses greater than symbol. Therefore, it is quadratic inequality. Another number 4, okay, there is an exponent 2 and it uses an inequality symbol which is less than or equal to. Therefore, there is quadratic inequality. Number 5, there is a degree of 2 and it uses a greater than symbol. Therefore, this is quadratic inequality. Now, as you can notice, quadratic inequality is a mathematical statement that relates a quadratic expression as either less than or greater than another. Number 1. Okay, let's describe this number 1. Is it quadratic inequality or not? Number 1 is not quadratic inequality because there is no inequality symbol. Okay, here. Number 2. Not quadratic inequality also because it uses an equal sign. Here, equal sign. While number 3 is not quadratic inequality. There is inequality symbol but this equation is not quadratic because the highest exponent is not 2. And number 4, okay, we have x minus 5 times the quantity of x minus 1. Just multiply x and x so we can get the highest exponent which is 2. And it uses an inequality symbol. Therefore, that is quadratic inequality because there is inequality symbol and the highest exponent is 2. Okay, or if we simplify this equation, we can get x squared minus 6x plus 5 greater than 0. Now, a quadratic inequality is mathematical statement that relates a quadratic expression as either less than or greater than another. So, a quadratic inequality in one variable is an inequality that contains polynomial whose highest exponent is 2. The general forms are the following where a, b, and c are real numbers with a greater than 0 but a is not equal to 0. So, we have ax squared plus bx plus c greater than 0. Ax squared plus bx plus c less than or equal to 0, ax squared plus bx plus c less than 0, and ax squared plus bx plus c greater than or equal to 0. Next, in solving quadratic inequalities, we need to find its solution set. The solution set of quadratic inequality can be written as a set and can be illustrated through a number line. Okay, remember this. To illustrate solution set on the number line, we need to consider the inequality symbols used in the given quadratic inequality. Number 1. As you can notice, these are examples of the solution sets that already solve. Number 1, x greater than negative 1. Now, how to illustrate this into number line? Alright, so we have here the critical point, which is negative 1. So, all numbers greater than negative 1 are the numbers to the right side of negative 1. And negative 1 is not included to the solution set. So, that's why we use a hollow dot. Number 2, y is less than or equal to negative 1. To represent that, okay, we use a solid dot, and all numbers that are less than negative 1 are at the right of negative 1. And we use a solid dot because negative 1 is included because there is an equal here. Number 3. So the critical point is negative 1. So what are the numbers that is greater than or equal to negative 1? Since there is an equal, so we are going to start with negative 1. And all the numbers that are greater than negative 1 are at the right side of negative 1. And number 4, x greater than 1. So the numbers that are greater than positive 1 can be represented by this, and 1 is not included because there is no equal sign here. And the solution sets are at the right side of the equation. Next, the x which is less than 1. So we can represent that by this number line. So 1 again is not included because there is no equal sign below. And all numbers less than 1 are at the left side of positive 1. In solving quadratic inequalities, we need to find each solution set. The solution set of quadratic inequality can be written as a set and can be illustrated through a number line. To illustrate the solution set of number line, on the number line, we need to consider the inequality symbols to use in given quadratic inequality. So here are the symbols that we have to consider. So if the symbol is greater than and less than, okay, we use the hollow dot. Okay? And it says that critical points are not included. Also, in the symbol less than, we use the hollow circle and the critical points are not included. In greater than or equal, we use the solid circle or the shaded circle. Shaded, meaning the critical points are included. And for the less than or equal, we also use solid circle. It means that critical points are included. Now, here are the steps to solve quadratic inequalities. The following procedures can be followed. Number 1, transform the given quadratic inequality into quadratic equation. Now, you're going to make sure to express into standard form. Number 2, solve for the roots or the critical points. Now, remember that the roots here are called critical points. Now, you may use the different methods in solving quadratic equations such as factoring method, completing the square and quadratic formula. Number 3, use the roots or the critical points to obtain the intervals. Number 4, choose a test point in each interval to determine the solution set. Number 5, graph the solution set. Number 6, check the obtained solution set in the original inequality. Example, 3x squared minus 3x minus 18 is less than or equal to 0. Now you're going to think of the numbers that are less than or equal to 0 using this expression. So first, okay, we're going to transform the given inequality into equation, meaning you're going to replace this inequality symbol into equal sign, then apply the method that we use in solving quadratic equations. So I prefer to use again the factoring method. The factor of 18 is 6 and 3. Okay, and 3x squared, so I use 3x and x. Okay, to check if our factors are correct, so multiply 6 and x. 6 times x is 6x. Then 3x times 3 is negative 9x. Minus 6 is positive 3. So we get the middle term. Therefore, our factor is correct. Next, use the zero factor property or equate these two factors into 0. So first, let's solve for 3x plus 6 equals 0. So from plus 6, it became negative 6 and minus 3, it became positive 3. Here, divide both sides by 3. Okay, so we can cancel the 3 here. So we have negative 6 divided by 3. That is negative 2. And on the other side, that is positive 3. Therefore, the solution sets are negative 2 and 3. By the way, these roots are called critical points because our given here is inequality symbol. Okay, first, the value of x which are negative 2 and 3 are critical points which can be used to obtain the following intervals. Okay, if x is less than or equal to negative 2 and x which is greater than or equal to 3. Now take note that negative 2 and 3 are included in the solution set because it uses the symbol less than or equal. Okay, so let's try first. Okay, the solution here is, or the critical points are negative 2 and positive 3. Now, we are not yet sure if the solution sets are in between negative 2 and positive 3. Okay, we're going to use the test points. Okay, so if we are really sure that the solution are between here, so let's choose the point if x is 0. X is between negative 2 and 3. So let's check if the answer is true. So in substituting to the original equation, so we have 3 times 0, the 0 here, which is found between. Okay, so we have negative 18 because 0 times 3 is 0, 0 times 3 is also 0, so we get negative 18. Less than or equal to 0, therefore it is true. What about the other solutions here? Okay, so let's try negative 3. That is found at the left side of the critical point negative 2. Okay, so let's try. By substituting negative 3 into the original equation, so we get 9. Is 9 less than or equal to 0? No, it's false. Therefore, negative 3 is not included to the solution set. Okay, how about the number at the right side of our critical point, 3? Okay, by substituting. Alright, so we get 36. Is it true? 36 is less than or equal to 0? No, because 36 is greater than 0. It's not less than or equal to 0. Therefore, the solution set here are not included. But if you're going to try such as negative 1, negative 2, 0, 1, 2, 3, all answers are true because they are all part of the solution set. Now, draw a line. from negative 2 going to positive 3. Okay, that's it. Okay, therefore, the solution set of the inequality is x is greater than or equal to negative 2 and less than positive 3 as shown as its graph is shown. Okay, meaning x is between negative 2 and positive 3. Last, and remember, you have to remember that in writing this expression, the lesser number must be at the left side and the greater number must be at the right side, and x is in between. Okay? Now, in other cases, now let's choose the greater than or equal symbol but using the same given. So we can use the same critical points such as negative 2 and positive 3. Now we're going to choose the test points. Okay? So the test points, it can be in between or apart. Okay? So since we uses the greater than or equal symbol, okay, so it says that the solution set of the inequality is x less than negative 2 or x greater than or equal to positive 3. So, let's check. Using the test points such as 0. Okay, if you use 0 in between, again, remember, we change the sign into greater than or equal. So, we uses 0. So, we obtain negative 18. Is negative number greater than 0? No, that is false. Therefore, the solutions in between are not included. If you're going to try 2, 1, 0, negative 1, the answer will be false. Okay? It's up to you if you're going to try. Okay, now let's try the number at the left side of critical point negative 3. So we can get 9 greater than or equal to 0. Is it true that 9 is greater than 0? Alright, that is correct. 9 is greater than or equal to 0. Therefore, the number here, which is negative 3 and so on, are part of the solution. Next, we use positive 4 or the number at the right side of the critical point 3. So let's check if we get the correct answer. Alright, so we get 36 which is greater than or equal to 0. Is it correct? Yes, because 36 is greater than 0. Therefore, the solutions that are included in this given are from left side of negative 2 or the numbers that are less than negative 2 included the critical point negative 2 because there is an equal sign below, and all numbers greater than or equal to positive 3 or the numbers at the right side of 3 including 3. So since they are separate or apart, so this can be shown into x less than negative 2, all numbers here. And the numbers here can be represented by x greater than positive 3. Okay? So here is the solution. Okay? Next, the solution for set of 3x squared minus 3x minus 18 less than 0 is the same with the other solutions shown before. Instead of using the solid dot, we use the hollow dot because we use here greater less than with no equal sign below. So the solution is the same. But hollow dot meaning the critical points are not included. Okay? So together with our greater than, there is no equal sign. So we uses hollow dot. Class, remember if the symbol is less than, Okay? The solution is in between. Okay? If the inequality is greater than, the solution is apart. Okay? So they are in opposite direction. So therefore, the solution set of the inequality is x is greater than negative 2 but less than positive 3. Okay? So on the other given, so since the given is greater than and the given are apart, not the same with this one because the solution is in between negative 2 and positive 3. Here it is. So the solutions are in opposite direction, but we can represent that into x less than negative 2, and negative 2 is not included because there is no equal sign here, or x is greater than positive 3. That's it. Now, tell whether given statements below illustrate quadratic inequality in one variable or not. You may translate into mathematical symbols to justify your answers. 4 more than thrice number is greater than 40. Okay, now let's represent this into mathematical equation. Okay, so we have 4 more than thrice. We have here 4 more than. I use addition symbol. Thrice a number. 3 times a number which is x. And it says that it is greater than 40. So I use this symbol and 40. Is it quadratic inequality or not? That is quadratic inequality. Number 2, the length of the floor is 8 meters longer than its width and the area is greater than 20 square meter. So let the length x plus 8 because it says that length is 8 meters longer than its width. And okay, there is no representation for width. So we use x for width. But the length is an additional of 8 because there is 8 meters longer than its width. And the area is 20 meters. Remember that the formula for area is length times width. Substituting to the formula, we get 20 equals the length, which is x plus 8, the width, which is x. Then multiply. So we get x squared plus 8x equals 20. Or by addition property of equality to obtain a standard form. Alright, it is not quadratic inequality. It is quadratic equation. Next, the width of rectangular plot is 5 meters less than its width, and its area is 84 meters square. So it uses 5 meters less than, okay, its width. Width is less than its length. So we don't have any representation for length. So we let length as x. Okay, so this is x. And it is less than 5 meters. So we subtract 5 into length. So we get width. And the area is 84 meter square. And the formula for area is length times width. So we can write area, which is 84, the width x minus 5, and the length, which is x. Okay, so we have 84 equals x squared minus 5x by distribution property or distributive property, and transform into standard form, and we get x squared minus 5x minus 84 equals 0, and that is not quadratic inequality. We only got the number 1 example as quadratic inequality. But I think this is not quadratic inequality. It is just inequality because there is no highest exponent, which is 2. Okay? This is not quadratic. It is just linear inequality. Okay? Now, in solving problems involving inequalities, number one, read and understand the problem. Number two, identify the given conditions and the unknown. Number three, represent the unknown using variable. Number four, devise an equation or inequality that corresponds to the given conditions and the unknown in the problem. Number five, solve for the unknown. Number six, check your answer. Now, I have here a problem. Mrs. Reina is planning to fence her vacant lot for a parking space. The desired length of the lot is 6 meters longer than its width. What will be the possible dimensions of the rectangular parking space if it should be less than 40 square meter? Hint: length times width is equal to the area of rectangle. Okay? So I already formulated here a representation for length and width. All you have to do is to solve for the critical points and for the possible solutions to fence the rectangular lot of Mrs. Reina. So you are going to answer that for your learning task. That's all for today. Thank you.